Welcome to our quick intro to bar graphs. Bar graphs are essential visual tools for representing data using rectangular bars. They are versatile, easy to interpret, and widely used across fields such as business, education, and most especially in nursing. Today, we'll explore everything from its history to its description, key terms, sample problems, solutions, interpretations, and its conclusion. Let's dive in.
Before any complexities in our lesson, now let me discuss to you the history of bar graph. Now, surprisingly, there are three people who are credited for discovering the bar graph. The first discoverer is a man called Nicole Oresme from the 14th century, and he used it in his publication, which is The Latitude of Forms. Now he used it to plot a constantly accelerating object against time. The second discoverer is a man called Joseph Priestley from 1765, and he used it in a chart of biography. Now it may look like a timeline, but it is a bar graph. Last but not the least is William Playfair from the 1780s, and he used it in his publication, which is the Commercial and Political Atlas. Now, the bar graph that he used is what we use nowadays.
Why bar graphs? Bar graphs are used to compare things between different groups or to track changes over time. However, when trying to measure change over time, bar graphs are best when the changes are larger. So, what is bar graphs? Bar graphs are the pictorial representation of data in the form of vertical or horizontal rectangular bars, where the length of bars are proportional to the measure of data. They are also known as bar charts. Bar graphs are one of the means in data handling in statistics. The bar graphs can be vertical or horizontal. The primary feature of any bar graph is its length or height. If the length of the bar graph is more, then the values are greater than any given data.
Bar graphs are useful for visually representing categorical data, comparing the sizes or frequencies of different groups, and identifying trends or patterns in the data. Next is a vertical or horizontal orientation. In a vertical bar graph, bars are plotted along the x-axis, while in a horizontal bar graph, bars are plotted along the y-axis. Axes in a graph provide the framework for plotting data points, with the x-axis representing the independent variable and the y-axis representing the dependent variable. Next is the bars. Bars in a graph represent data values or frequencies for each category or groups, with their lengths or heights directly proportional to the corresponding values or frequencies. For the labels in a graph provide essential information about the axis, data points, or categories, helping to clarify and interpret the graphical representation of data.
So here are the steps and procedure on how to make a bar graph. So the first step is to identify data. Determine what data you want to represent on the bar graph. This could be anything from sales figures to population demographics. Next step is to choose axis. Decide which variable will go on the x-axis, which is the horizontal, or on the y-axis, which is the vertical. The x-axis usually represents categories or groups, while the y-axis represents the values you are measuring. Next step is to determine the scale. Choose an appropriate scale for each axis. This ensures that your data fits well within the graph and is easy to interpret. The fourth step is to draw axes. Draw the x and y axis on your graph paper or on your digital graphing tool. Label each axis with the variable it represents and include the scale you've chosen. Next is to draw bars. For each category or group on the x-axis, draw a bar whose height corresponds to the value of the variable on the y-axis. Ensure that the bars are evenly spaced and of uniform width. And the last step is to label the graph. Label each bar with the value it represents, either directly above the bar or at the end of it.
And now, let us delve into the world of sample problems. Sample problem 1. The Nursing College of Nightingale is planning to offer a new combined elective course based on student interest. However, they can only choose 2 elective courses to combine this semester due to resource constraints. The college aims to maximize student engagement. Which combination of 2 elective courses should the college introduce to cater to the maximum number of interested students? We have here the bar graph containing the elective courses and the number of students. To solve this problem, we need to identify the combination of 2 elective courses that, when added together, result in the highest number of interested students. It requires analyzing the bar graph to determine the combination with the maximum total number of interested students. We have different elective courses such as critical care nursing, community health, palliative care, neonatal nursing, and psychiatric nursing. Now we have here the solution and the answer. Looking at the bar graph and calculating the total number of interested students for each combination, we have number 1, critical care nursing plus community health, 35 plus 50 equals 85. Number 2, critical care nursing plus palliative care, 35 plus 25 equals 60. Number 3, critical care nursing plus neonatal nursing, 35 plus 40 equals 75. Number 4, critical care nursing plus psychiatric nursing, 35 plus 30 equals 65. Number 5, community health plus palliative care, 50 plus 25 equals 75. Number 6, community health plus neonatal nursing, 50 plus 40 equals 90. Number 7, community health plus psychiatric nursing, 50 plus 30 equals 80. Number 8, palliative care plus neonatal nursing, 25 plus 40 equals 65. Number 9, palliative care plus psychiatric nursing, 25 plus 30 equals 55. And lastly, neonatal nursing plus psychiatric nursing, 40 plus 30 equals 70. The combination of elective courses that caters to the maximum number of interested students is number 6, community health plus neonatal nursing, with a total of 90 interested students. Therefore, the Nursing College of Nightingale should introduce the combined elective course of community health and neonatal nursing to cater to the maximum number of interested students.
Sample problem number 2. Actually guys, we have 2 sets of questions here on sample problem number 2. So let's begin. Let's proceed to the first question and the given graph. So here is the given graph. Estimated school budget for a day. So we have fare, lunch, snacks, and emergency school budget. So first question, what is the ratio of the estimated school budget on fare and lunch to the estimated budget on snacks and emergency school budget? So by getting the ratio of the given problem, we have to find the sum of the grouped estimated school budget, which is the fare plus lunch, to the emergency school budget plus the snacks. So here is the solution. Okay, so as stated earlier, but firstly we have to categorize the graph as this. Since given in the graph that fare is to 35, lunch is to 85, snacks is to 40, emergency school budget is to 100. So therefore, we have now the ratio that 35 plus 85 to 40 plus 100. So we just have to sum up this grouped estimated school budget. So first is 35 plus 85, it gives us 120, and also 40 plus 100 is to 140. Therefore, the ratio is 120 to 140. But take note, 120 to 140 can be simplified. So it can be simplified as 6 to 7. So therefore, the ratio of the estimated school budget on fare and lunch to estimated school budget on snacks and emergency school budget is 6 to 7. And that is our answer of the first question. Let's proceed to the second question. And the same given graph actually here, guys. So second question, based on the graph, if a student doesn't spend 50% of his estimated school budget on emergency school budget and lunch, what is the total estimated school budget for a day? So to solve the problem, we have to get the total estimated budget first, since it looks it since it's looking for the total estimated school budget for a day if a student doesn't spend 50% on emergency school budget and lunch. And after that, we have to get the 50% of the emergency school budget and lunch as stated there in the question. Then after getting the 50% of the two, we have to find the difference of the total estimated school budget and the result of the 50% on lunch and emergency school budget. So here is the solution to solve the problem. Okay, guys. So first is we have to get the total of the whole estimated school budget. So as given on the graph, so 35 plus 85 plus 40 and plus 1000 plus 100 is total of 260. And second, we get the 50% of both emergency school budget and lunch. So lunch is to 85, so the 50% of 85 times 0.50 is 42.5. And then emergency school budget is 100, then the 50% of 100 is 50 because 100 times 0.50 is 50. So we have the total of the two, 50%. So 42.5 plus 50, it gives us 92.5. And lastly, difference of the total estimated school budget and 50% of both givens. So total estimated school budget is 260. Then the total 50% of lunch and emergency school budget is 92.5. So we have to look for the difference. So 260 minus 92.5, it will give us 167.5. So therefore, the answer is the total estimated school budget for a day if a student doesn't spend 50% of his emergency budget and lunch is 167.5.
So here's another problem that shows the use of bar graph. A survey was conducted at a public high school in Minglanilla, Cebu regarding reproduction. Grade 12 students were asked about the preferred sources of information regarding the sexual reproductive system. Based on the results, answer the following questions. 1. What is the most preferred source of information by the students and what percentage? 2. What is the least preferred source of information and what percentage? So to easily answer this problem, we should first make a bar graph. A bar graph is used to quickly identify the most and least preferred sources of information. The most preferred sources of information by the students are the doctors with 20 votes, followed by school teacher with 15 votes, then followed by mother and films or videos with 10 votes, then followed by sister, other family members, friends, and other sources with 5 votes. And lastly, the least preferred sources of information with 0 votes are the father and brother. So now that we have found the most and least preferred sources of information, we now have to find its percentage. But first, we're gonna have to find the total number of votes. So to do this, we have to add up all the votes. 20 votes for doctors, plus 15 votes for school teacher, plus 10 votes for mother, and 10 votes for films or videos, plus 5 votes for sister, 5 votes for other family members, 5 votes for friends, and lastly 5 votes for other sources, is equal to 75 votes. And now we're gonna have to find its percentage by dividing the number of votes by the total number of votes. So the most preferred is the doctor with 20 votes. So 20 divided by 75 is 0.27 times 100 is 27%. Now we're gonna have to find the percentage for the least preferred sources. So the least preferred sources is father and brother with both 0 votes. So 0 divided by 75 equals to 0. 0 times 100 equals to 0%. So the percentage for the least preferred sources is 0%. Therefore, the most preferred sources of information regarding sexual reproductive system by the student is the doctor with 27% of the votes. And the least preferred sources of information regarding sexual reproductive system by the students is father and brother with 0% of the votes.
Okay, for conclusion of the sample 2 and 3, with the sample 2, we have identified how to get the 50% total estimated school budget for a day of the student and how to get the ratio of the fare, lunch, snacks, and emergency school budget. So therefore, we can conclude with the use of the bar graph. It is really helpful and the student nurses can determine the school budget on a daily basis. With the sample 3, we have identified the least and the preferred source of information by the students regarding the sexual reproductive system, with still the same help of the bar graph itself. So therefore, the student nurses can get the same result using the bar graph and its formula.
Now that you have gotten this far, I assume you have learned what a bar graph is, how to gather data, how to chart the data, how to construct a bar graph, and how to answer questions using information from the graph. Not only have you learned about graph, but you also got to learn about the history, steps and procedure, and the sample problems with solution that we have presented just for you. Also, I would probably assume that we have achieved the objectives for this discussion. Generally, to sum it all up, bar graphs are a valuable tool for representing and analyzing data in a visual and easily understandable format. They provide a clear and concise way to present categorical or group data, making it easier to identify patterns, trends, and comparisons.
As we end our exploration of bar graphs, remember, it's not just rectangles and lines, but windows into valuable insights. Keep graphing, keep learning, and keep making informed decisions. Until next time, thank you. These are our references or sources used.